running up this entire chain between copper atoms. So just like last time, there is actually an equation that tells us the number of bonds in a chain, or bonds per chain of the wire. And this is equal to the length of the wire divided by the length of a single bond. And we, of course, have both of these values once again. So this is really just a matter of plugging them in and calculating them. So we have the length of the wire is equal to 3 meters, and then divided by the length of one bond, which is equal to 2.57 times 10 to the negative 10th meters. And we just have to calculate this. And the number that we get for the number of bonds per chain is 1.17 times 10 to the 10th bonds per chain. And so this huge number of bonds is present in every chain, every single one of these chains running from top to bottom of this wire. And that is a lot of bonds, and it is a way of telling us just how many copper atoms are present in just one chain of this wire. So with that, we have finished part B of this problem, and we can move on to part C.